So far we studied two methods of adding vectors. One is method of triangle and the other is parallelogram method. Both the methods might lead to the same result, but triangle method is not going to give you the formula. Parallelogram method gives the accurate formula for finding the their two interaction poles. One step ahead, now we'll study what is the polygon method of vectors. Polygon method. If you want to add so many vectors, means for two vectors you have triangle and parallelogram method. Vectors are more in number greater than 2. Then in that case you have to follow this method. What is this method? You have many vectors A, B, C, T. You have to add them together. Suppose this is equal to R. Then what you'll do is go on drawing each vector one by one. One by one, when I say one by one, it simply means that when you finish up one vector, start from the end point, the initial point of the next one. So this is A, B, suppose C was this way. Here you will be drawing all the vectors as it is, means you are not going to change the variable direction. You will simply put the vectors as they are. So I am putting A, B, C, and suppose this was vector D. These are the four vectors that you have to add. What remains is here the initial point of the first vector, final point of the last vector. This is the resultant. Now this is the polygon. Actually it's a pentagon. In pentagon you have four vectors in cyclic order. The last vector is their resultant. In terms of n vectors, you might say, if in a polygon n minus 1 vectors are represented by n minus 1 side, then the last side starting from the initial point will give the resultant of all the vectors. This is true for 5 sides, for 6 sides, and for any number of sides. This is polygon method. So triangle method, parallelogram, and finally polygon method for any number of vectors. There was one very important law that's known as law of triangle. Suppose a law of triangle. Suppose you have three vectors, and all the three vectors can be represented by three sides of a triangle. Have I missed something? Yes. You need to say that three sides of a vector in cyclic order, because when you are talking about the direct vector, you must quote the direction. Unless you point out the direction, you are not furnishing the information of vector completely. So again, I'll repeat, three sides of a vector, three sides of a triangle are representing three vectors in cyclic order. Then their resultant shall be equal to 0. These are the three vectors which are represented by three sides of a triangle in cyclic order. When you say cyclic order, it simply means that start from one point, don't raise the pencil or your finger, and you come back to the same starting point, then the resultant will be 0. It also confirms and gives you the hint that you started from one point and came back to the same point. Obviously, the displacement was 0. So, this is one very important law known as law of triangle. The resultant is a 0 vector. Again, I would repeat, three vectors are represented by the three sides of a triangle in cyclic order. Resultant is 0. Same thing in terms of polygon. If there are many vectors and they are being represented along sides of a polygons in cyclic order, their resultant will also be 0. This would be known as law of triangle. You talk in terms of polygon, that will be known as law of polygon. Finally, some important things to be remembered. Throughout, you need to remember these 3 points, that two unequal vectors, visually 5 and 3. 5 plus 3, it's never going to be 0. 5 minus 3, it's never going to be 0. So you can say two unequal vectors can never give the resultant 0. Second thing, you are having three coplanar vectors. They might give you the resultant 0 if they form triangle in cyclic order, and if they are not making the triangle in cyclic order, the resultant shall not be 0. Means three coplanar vectors may or may not give the resultant 0. Whereas you can say confidently, if there are three vectors and they are in different planes, their resultant can never be equal to 0. If there are three non-coplanar vectors, their resultant will never be equal to 0.